Hello guys, welcome to Java Developers YouTube channel. Today we are discussing problem number 6, Armstrong number, pattern number 1. First we go for the what is an Armstrong number, then we go for the dry run with the code and then we'll write the code. Okay, let's assume that given number is 1, 2, 3. How many digits we have? 1, 2, 3. Total digits are 3, right? Total number of digits is 3. And if you do power the each digit with the number of digits and then do the summation, if you get the same result of 150 123, then you can say that it's an Armstrong. Okay, then you can say that it's an Armstrong. But we will do the summation with the powers. What is the 1 cube? 1. What is the 2 cube? We will get 8. What is the 3 cube? You will get 27, which is 28, 29, 30, 36. Right. Our summation will give the 36, whereas our question is 123. So it's not an Armstrong number. We will try one more example, which is 153, which is 1 cube, 5 cube, 3 cube. If that will result in 153, then you can say that it's an Armstrong number. What is a 1 cube? We have 1. What is 5 cube? 125. And what is 3 cube? You will get 27. 27 plus 1, 28. If you do the 13, 5, 153, which is matching with the question. So you can say that 153 is an Armstrong number. Okay. And what is the next example? We'll do the one more example with the 4 digits number, and that is 1434. Sorry, 1634. Okay, 1634. If that, what is the total number of digits we have? 4. 1 to the power of 4, 6 to the power of 4, 3 to the power of 4, 4 to the power of 4. If that will resulted in 1634, so you can say that given number is Armstrong. And what is a 1 to the power of 4? You will get 1, right? 6 to the power of 4, you will get 250. No. I mean, you will get like 1296, I think. Yeah, we get 1296. And what is 3 to the power of 4? You will get 81. What is 4 to the power of 4? You will get 256. If that summation, let's do the summation, and 256, and we have to add this as 82, 12, 12, 12, 14, and 10, 18, 19, 20, 23, and 6. Yes, it was matching, right? So you can say that 1634 is an Armstrong number. Okay, and just rewrite the code first. Okay, just rewrite the code, and let's, if you want to get this, I mean, if you want to fully understand this, you must watch from the problem number 1, because the steps are similar. Most of the steps are similar from the problem number 1. So this is a problem number 6. You should have some basic idea regarding from problem number 1 to the problem number 5. Then you can easily understand the code here. Okay, and let's take int of number. Okay, what is number? And we know that 153 and 1634 are the Armstrong numbers. I have taken the one number, that is 153. Okay, yeah, and int of ORI, that I was passing the name. That means here ORI will be holding 153 constant overall the problem, but whereas num will goes to the different operations, right? Yeah, and let's take the sum, because we are doing the power to the sum, right? I mean, total number of digits is 3. So 1 cube, 5 cube, 3 cube. That means we are doing the sum here, right? Then we are getting 153 of each power, right? So we have to take the summation variable, then write the code. What is the first code? While number must be greater than 0. It's a mandatory thing. What the user has been entered, it must be greater than 0. Then what we have to take? Int of remainder equals to num modulo by 10. What will happen? Among 153, we will pick 3. Okay, then sum is equals to sum plus. Okay, how many digits we taken here? We have taken 3 digits, right? So what we have to do now? Remainder into remainder into remainder. In a case, if you take 4 digits, okay, in a case if you take 4 digits, we have to increase another remainder. but we have taken only the 3 digits, right? So, and I have taken only 3 digits, so I was using only 3 reminders. Okay, and after that we need to remove the every number, which is num is equals to num by 10. That means we are eliminating the last 2 digits step by step until it reaches to 0. Okay, that's the code. And after that, what we have to do, we need to compare if sum we get is matched with the ORI, which is a constant number we have taken here, right? If that will be matched, you can say that it's an Armstrong number. Okay, or else you can say like it's a not an Armstrong number, not an Armstrong number. Okay, and that's all about this video, and I mean about this problem, and we will understand the intuition first and then we write the table for that. Okay, yeah. And first of all we take in the num, right, which is, okay, let's take I mean first we take in the num, which is num is equals to 153, and we have stored that in the ori will stays throughout the problem, which is 153. So we start from the num. Okay, then what we are doing, initially what is the sum and what is the remainder and what is the n is equals to, that is num is equals to num by 10, that is removing with every digit for the case of writing, right? Yeah, what we have to do, first we take in 153 and initially sum is 0. Okay, first we take in 153, initially sum is 0, and what is the remainder, 153 modulo by 10, that will give a remainder as 3. Already we seen that 153 divided by 10, it will give 15 times as 150, then it will give a remainder as 3. So you will get the remainder 3, and among 153 by 10, it will eliminate the 3 and it will give the value like 15. Okay, yeah. And before that we are missing something, right? That means in between that, yeah, we missed something uh that need to be like, yeah, before going to that, we need to do the sum here, we need to update the sum, right? Yeah, how we will update that, sum is equals to reminder, sum is equals to sum plus reminder into reminder into reminder, and then we need to go for n is equals to n by 10. Okay, and we have taken 153 initially sum 0, and by 153 modulo by 10 you are going to get 3 as a reminder, and initially sum is 0. What is 3 into 3 into 3? You will get like 27. Okay, yeah. And next among 153 by 10, and it will remove the 3 and that will be holding 15. And what is the number we have, 15? What is the sum updated? It's 27. And what is the number 15 we have, modulo by 10, it will give the 5. And what is the sum we have, 27 plus 5 into 5 into 5, you will get 125, right? 125 plus 27, you will get like 12 5 152, I think so, yeah, you will get like 152. And 15 by 10 is like, it will remove the 5 and it will give the value as 1. Okay, then we have the number is 1 and the sum is updated to 152, and then what is the number is 1 modulo by 10, it will give the value as 1. And 152 plus 1, it will update it to 153, and we have the 1 by 10, which is 0.1, that will use the 0. So the while loop will come out of that, right? while loop will fails the condition that will come out of the code. So like after that we need to compare the values of original. Okay, we need to compare the value of original with the sum. Okay, then we'll get the code of it. I mean here we are doing the hard coding. Okay, I mean if we have 1634, we have to take one extra reminder here. Okay, that means we are hard coding. If your user enters 6-digit number, you have to add like again 6, which is a hard code, and it's not a good practice, and it's a problem number 1, which is a pattern is 1. So we'll write the code for that. For that, open the Eclipse and create a class like Armstrong 1. And what is the number we have taken? Int of num is equals to 153, and int of ori equals to num. And what is the first thing we have to take? Int of sum is equals to initial is 0, while num must be greater than 0. Okay, here num is greater than 0. Yes, that's. And what we have to take? Int of remainder is equals to num modulo by 10, and that will use the 3 as a remainder, and we have to perform the sum operation. Sum is equals to sum plus remainder into remainder into remainder, because we have taken the 3 digits number. Then num is equals to num by 10, that means it will remove the last digit every time. Okay, let's confirm that if ori double equals to given sum, if the sum and ori is same, then we have to say that it's an Armstrong. Okay, then we have to say that it's an Armstrong number. Okay, or else we have to say like it's not an Armstrong number. Not Armstrong number. Okay, for that check, please run our code and you will see like it should be the Armstrong number. Okay, if I change to 123, and what is the output we are going to get? It's not an Armstrong number. If I change my 1634, what is the answer you are going to get? Because we are not dividing with the another remainder. Our code is for only 3 digits, but if I again implemented added remaining digit, it will say it's like it's an Armstrong number. Okay, this is the drawback of this code, and it's a pattern number 1. So if you have any doubts, just comment me below. Thank you for watching. Please subscribe to our YouTube channel.